Good morning, dear students. Today, our focus will be on another data structure as a queue. But before moving towards queue as a data structure, I would like to revise the things which we have seen in the previous lecture. We already have gone through the concept of the data structure. What do you mean by data structure? Basically, data structure is a way for storing and arranging the data so that it can be used efficiently. We have seen type of the data structure, linear data structure and non-linear data structure. In linear data structure, data is arranged linearly, sequentially, and examples of linear data structure are stack, queue, linked list. While in case of non-linear data structure, data is arranged hierarchically, and we have seen examples of non-linear data structure as graph, tree, etc. Also, yesterday we have gone through stack as a data structure. Basically, we have seen stack is nothing but it is a data structure in which an element which is inserted last it's come out first. Once again I repeat, stack is a data structure in which an element which is inserted. Stack is a data structure in which we insert data in such a way that element which is inserted last is come out first. That is why it is known as LIFO data structure. Today our focus will be on queue. As like stack, queue is also a linear data structure. Queue is a data structure in which an element which is inserted first it's come out first. That is why queue is known as FIFO kind of data structure. In this lecture we will see the basic concept of the queue. What is queue? What are different types of queue? That is linear queue, circular queue, double-ended queue, priority queue. We also will see algorithm, how to implement linear queue, circular queue and so on. Also, we will see what are the drawbacks of linear queue, how these drawbacks get overcome by circular queue, and finally we will list out various applications of the queue. So basically what do you mean by queue? I already have told queue is nothing but it is a linear data structure in which an element which is inserted first it's come out first. That's why queue is also known as FIFO kind of data structure. There are various types of queue: linear queue, circular queue, double-ended queue, priority queue. Now I will explain these types one by one. First, let us focus on linear queue. Basically, uh, we consider any queue. It is having two ends. An element get inserted from rear side and an element get deleted from front side. So for a queue there are two ends, unlike stack, because in stack there is only one end. In case of queue we are having both ends, front and rear. An element get inserted from rear side and an element get deleted from front side. uh, Let us consider initially we a q of size 5. So in C we declare it like int q of 5. uh, then front equal to -1 and rear equal to -1. Basically front equal to -1 indicate q is empty. Okay, in stack, whenever we try to push an element into the stack, we check first whether stack is full or not, and how we have checked if top equal to max -1, where max is the size of the stack. At that time we can say stack is full, and file popping out element from this stack, we have checked whether stack is empty or not. If it is empty, we cannot pop the element from this stack. Similarly, in case of queue, we can insert an element into the queue. Insert operation into the queue is known as enqueue operation, and we can delete the element from the queue. To delete an element from the queue is known as dequeue operation. So while we try to enqueue, we have to check whether queue is full or not, and 5 we try to dequeue, we have to check whether queue is empty or not. If queue is full, we can't insert an element into the queue. Similarly, as a queue is empty, we cannot delete an element from the queue. Okay, if we consider an EDT of the queue, it is having following function. Its full function, we check whether queue is full or not. Its empty function, we check whether queue is empty or not. Also we are having enqueue operation as well as dequeue operation. So we will see these functions one by one. Let us consider a queue of size 5. Here I have shown a queue of size 5, and I initialize front equal to -1, rear equal to -1. I already have told an element get inserted from rear side. That is why when we try to enqueue, we have to increment the value of the rear, and when we try to remove the element, at that time we have to increment the value of the front. Initially front equal to -1, rear equal to -1. So basically, suppose the size of the queue is 5. At that time, as we know, start index is always 0. So last index will be 4. We can move rear from 0th index to at max 4th index. So whenever a rear is pointing at 4th index, definitely we can say queue is full. So this is the algorithm to check whether queue is full or not. If rear is pointing to 4th index, basically I have taken here size of queue as 5. In general, if the size of queue is n, and if rear is pointing at n minus 1 index, we can say queue is full. It will return 1, otherwise 0. Similarly, next algorithm to check whether queue is empty or not. In stack we have seen at top equal to -1, stack is empty. Similarly here, if rear is pointing to -1 or the value of rear is greater than that of front, oh my god, no need to consider another condition. There is, I think, only one condition. If rear equal to -1, definitely we can say queue is empty. That is, no need to write a second condition for is empty. How to check whether queue is empty or not? If rear is pointing to -1, uh, return 1, otherwise return 0. Next, NQ operation. I already have told, as we try to NQ, first we have to check whether queue is full or not. Suppose right now situation is like this. We have declared queue of size 5, front equal to -1, rear equal to -1, and I would like to insert, I would like to NQ 10. 10 value, it will get stored into X if it's full condition. Oh my god, but it's full if rear equal to 4, but as we know front and rear both are pointing to -1, and that is why uh, it will return 0. Automatically else part get executed. We get enter into else part if front equal to -1. Yeah, this is so because the value of front and rear is current front and rear value is -1. If front equal to -1, yes, it is equal to -1. Front equal to 0, front comes at 0th index, rear plus plus, rear value also becomes 0. Q of 0 equal to 10, so 10 gets stored at Q of 0. Similarly, I would like to insert 20. 20 gets stored into X if it's full condition. No, because rear is at 0th index. Its full condition is true when rear is at 4th index. Again we get entered into else part. If front equal to -1, no, now it is not equal to -1 because previously we have set front at 0th index. So from this moment only rear get incremented, rear becomes 1, and Q of 1 equal to 20. 20 gets stored at first index. Again, if I would like to insert 30, similarly its full condition is false. Front equal to -1 is false. Again rear plus plus, rear get incremented, it becomes 2. Q of 2 equal to 30, and in this way only rear value it get incremented when you in this way. Suppose if we try to NQ 10, 20, 30, 40, 50 at that time, uh, suppose I have performed NQ operation 5 times. Right now the queue situation it will be like this: 10 it will get stored at 0th index, 20 at 1, 30 at 2nd, 40 at 3rd, 50 at 4th. Right now as we can see rear is pointing to 4th index, and if we try to insert one more element, let us see what happens. Suppose I would like to insert 6th element as a 60. X becomes 60 if its full condition call is given to its full. Oh my god, if rear equal to 4, yes, rear is pointing at 4th index, return 1, it will return 1. That is, we can now get a message queue is full. So this is how NQ operation is performed. Basically, before inserting into the queue, we have to check whether queue is full or not. If it is full, we can display message queue is full. If it is not full, we have to check whether an element is the first element. If it is the first element, at that time we have to increment both front and rear so that front and rear points to 0th index. And next, now onwards, if you try to insert at that time only rear get incremented, and once we insert 5 element as shown in the figure, front is set to 0 and rear is set to 4. Okay, so this is how NQ operation get performed in case of linear queue. Now uh, let us try to delete an element from the queue. I already have told to delete an element from the queue is known as dequeue operation. Uh, so if you try to delete, definitely element which is at different, that is 10, it get deleted. So let us see how dequeue function works. I already have told, while dequeuing element from the queue, we have to check whether queue is empty or not. So right now situation is like this. We have inserted 5 elements. The situation is like this. Front is at 0th index, rear is at 4th index. Now if we try to dequeue operation, if is empty, call is given to is empty. If rear equal to -1, no, because rear is at 4th index, so it will return not 1, it will return 0. That its condition is false. We get entered into else part. Deleted job id, that is deleted element equal to q of front. The current front value is 0, that is deleted job id is q of 0, that is 10. We have to check whether front equal to rear. No, front is at 0, rear is at 4. Again this condition is false. Else part get executed and front value get incremented. Now front is set to 1. Again if we try to dequeue, call is given to is empty, but queue is not empty because rear equal to 4. Again else part get executed. Deleted job id equal to, we get q of 1, that is 20. Again front and rear both are not equal. Again else part get executed. Again front plus plus, front becomes 2. Again if we try to dequeue, again queue is not empty. Again else part get executed. Again we get deleted job id as 30. In this way, if we remove all the 5 elements, 10, 20, 30, 40, 50, when we remove 50, at that time basically what happens, front and rear both points to 4th index, both points to 4th index. And now see how it works. If is empty, no, else part get executed. Deleted job id equal to q of front, that is q of 4. We get deleted job id equal to 50. Now if front equal to rear, yes, front and rear both are pointing to same location. uh, Now this condition is true. Front equal to -1 and rear equal to -1. That is, when front and rear points to same index, the meaning of this statement is like all elements from Q get deleted. So definitely we have to reset front and rear equal to -1. So this is how DQ works. So before deleting element from the queue, we have to check whether queue is empty or not. Right now we have deleted all the elements from the queue. Front and rear both are pointing to same index. If a situation, if front equal to rear is true, now front equal to -1 and rear equal to -1. Right now situation is front and rear both are pointing to -1. And still if we try to dequeue, still if we try to perform dequeue operation, at that time if call is given to isEmpty function, and isEmpty function, if rear equal to -1, yes, now front and rear both are pointing to -1, it will return 1. That is, we get message, yes, queue is empty. So this is how we can perform dequeue operation. In this way, up till now we have seen how linear queue get implemented, and what is the algorithm for NQ operation, what is the algorithm for DQ operation. This linear queue is having several drawback. Let us see what is drawback. Consider this as a linear queue which is of size 5, and we have inserted 10, 20, 30, 40, 50, and we have deleted first two elements. After deleting first two elements, front is pointing to second index and rear is pointing to fourth index. I repeat once again, linear queue is having several drawback. uh, what is drawback I will tell. Consider queue of size 5. After inserting 10, 20, 30, 40, 50, front is at 0, rear is at 4. Then I delete first two element from the queue. After deleting first two element, front it will point to second index and rear it will point to fourth index. And if we try to insert one more element, if we try to perform NQ operation, see how it works. Suppose I would like to insert 60, x becomes 60 if its full call is given to its full, and if rear equal to 4, yes, rear is pointing at fourth index and we get message q is full. But is it full? We can't insert 60, still we are having previous location as empty. This is the drawback of linear queue. So what is drawback of linear queue? We cannot insert an element in the previous position. So this drawback of linear queue is overcome by the concept of circular queue. Circular queue, again, it is a linear data structure in which the operations are performed based on FIFO basis, and the last position is connected back to the first position in order to make a circle. Circular queue is also known as ring buffer. So let us see how it works. Circular queue. In circular queue, just I already have told, it is like ring buffer. Consider a circular queue of size 5, 0th index, first index, second, third, and fourth. These are the four indices. And here, instead of incrementing front and rear linearly, we try to increment front and rear as circularly by setting formula as front equal to front plus 1 mod size of q, rear equal to rear plus 1 mod size of q. Here consider a q of size 5. Again, in case of circular queue also, we have to check whether while inserting we have to check whether queue is full or not. While deleting we have to check whether queue is empty or not. Now when we can say queue is full, so this is the condition which indicate queue is full if front is pointing at 0th index and rear is pointing at 4th index. Just like if front is pointing at 0th index and rear is pointing at 4th index, that is last index, it means all the indices are full, and here we do not have any chance to insert sixth element. That is, if front equal to 0 and rear equal to last index, or rear plus 1 equal to front, we can say queue is full, otherwise it is not. Similarly, how to check whether queue is empty or not? If, as usual, rear equal to minus 1, if rear is equal to minus 1, we can say queue is empty, otherwise it is not. So let us see how NQ function works. So this is the NQ function. Consider Q of size 5. Initially front equal to -1, rear equal to -1, and the element which is inserted first is 10. X becomes 10. Call is given to its full function. Right now front and rear are pointing to -1. Yeah, both the conditions are not true. That its queue is not full. So we get enter into else part. If front equal to -1, oh my god, yes, the value of front is -1 because front and rear both are pointing to -1. If front equal to -1, yes, it is equal to -1. Front equal to 0. Then rear plus 1 mod 5, that is -1 plus 1, 0 mod 5 equal to 0. Front is 0, rear is 0, and 10 get inserted at q of 0. When we try to enqueue second element as a 20, x becomes 20. Again, call is given to its full function. Now front is at 0, rear is at 0. Again, call is given to its full function. Both the conditions are false. It will return 0. Mm, uh, Again we get entered into else part. If front equal to -1, no, now it is set to 0 previously, so rear get incremented. See how it get incremented. Rear equal to rear, that is 0 plus 1 mod 5, and it is equal to 1. Rear becomes 1, and 20 get assigned to q of 1. In this way, if we try to enqueue 30, 40, 50, at that time front it becomes 0 as it is, and the value of rear get incremented. Initially it was 0, then 1, 2, 3, 4, and when rear reaches at fourth index, see, if we try to insert next element as a 60, see how it works. Right now front is at 0, rear is at 4. We have already inserted 10, 20, 30, 40, 50, and if we try to insert 60, see what happens. X becomes 60. Call is given to its full function. Yeah, its full function. If rear equal to 4, yeah, rear is pointing to 4, and front equal to 0. Oh my god, yes, front is also pointing to 0. Both the conditions are true. It will return 1. That is, we get message q is full, and 60, that is sixth element, it never get entered into the queue. So this is how enqueue function works. Now dequeue function, the concept is exactly same. We enqueue from rear side, we dequeue from front side. Up till now we have seen how we have inserted element into the queue. We have inserted from the rear end. The concept of the queue is we can delete from the front end. So right now situation is we have inserted 10, 20, 30, 40, and 50, and front is pointing at 0, rear is pointing at 4. Now if we try to delete element, definitely the element which is at the front and the here front is at 0, that is 10 is at the front, definitely 10 get deleted and front get shifted to next. Now see how it works. Now I would like to perform dequeue operation. Call is given to dequeue function. We enter into dequeue function. Again we check whether queue is empty or not. As we know front is at 0, rear is at 4. So call is given to is empty function. If rear equal to -1, absolutely not, because rear is pointing to fourth index. So this it definitely it will return 0. That is, we get entered into else part, and deleted job id equal to q of front, that is q of 0, that is 10. Deleted job id as 10. If front equal to rear, absolutely not. Front gets shifted to next index. Front equal to front plus 1, that is current front value is 0 plus 1 mod 5, and front it is equal to 1. Now front is get set to absolutely first index. Right now front is at 1, rear is at 4. Similarly, again if we try to dequeue element which is at the front, that is 20, it get deleted. Now see how it works. Again, I would like to perform dequeue operation. Call is given to isEmpty function. If rear equal to -1, absolutely not, so definitely it will return 0. Again we get entered into else part. Deleted job id equal to q of front, deleted job id equal to q of 1, and it becomes 20. Now front equal to rear, absolutely not, we get entered into else part and front get shifted to next. Now front equal to current front value is 1, 1 plus 1 2, 2 mod 5, front equal to 2, front is at 2. In this way we have deleted 10, 20. Right now front is at second index, rear is at fourth index. Now we have to see how circular queue overcome drawback of linear queue. Consider this situation. Initially we have inserted 5 element, 10, 20, 30, 40, 50. At that time front is at 0th index and rear is at 4th index. Now suppose I perform one delete operation. At that time 10 get deleted and front get shifted to next location, that is now front is at first index and rear is at fourth index. Now if I try to perform NQ operation, now see what happens. I would like to NQ 60. Now see how NQ works. X becomes 60, call is given to its full function. If rear equal to 4, yes, and front equal to 0, no, front is at 1. Definitely uh, it will return 0 because queue is not full. We get entered into else part. If front equal to -1, absolutely not. Rear value it get incremented, rear equal to rear plus 1 mod 5, current rear value is 4, 4 plus 1 5, 5 mod 5, and rear equal to 5 mod 5, that is it is equal to 0, and 60 it will get inserted at q of 0. So in this way we can insert an element at previous location, which is absolutely not possible in linear queue. We can say that the drawback of linear queue is get overcome by the use of circular queue. In linear queue we increment the value of front and rear as linearly, like front equal to front plus 1, rear equal to rear plus 1. But in circular queue, now I have updated formula and it is like front equal to front plus 1 mod size. Here I have taken the size 5, therefore here my formula becomes front equal to front plus 1 mod 5, rear equal to rear plus 1 mod 5. In this way uh, the drawback of linear queue is we cannot insert element in previous empty location because rear we are incrementing linearly, so we don't have chance to move it to previous location. But in case of circular queue, when, as we know, 0th position is empty and our rear is pointing at 4th index, if we try to insert one more, rear equal to rear plus 1 mod 5, current rear is 4, 4 plus 1 5, 5 mod 5, and it is 0, and we can insert element at 0th index. In this way the drawback of linear queue is get overcome by the use of circular queue. Okay, next type of the queue is double-ended queue. In short, it is also known as DQ. Uh, it is a generalized version of queue data structure which allows insert and delete at both ends. This is the special property that is, we can say, when we make use of double-ended queue, as name suggests, DQ, double-ended queue. In case of double-ended queue, we perform insert operation from the rear side, and we perform uh, DQ operation from the front side. But in case of double-ended queue, we can perform insert operation from the rear as well as from the front. Similarly, we can perform delete operation from the front as well as from the rear. DQ is having two types: input restricted queue and output restricted queue. In input restricted queue, we can perform insert operation from the rear as well as from the front. Similarly, in output restricted queue, we can perform delete operation from the front as well as from the rear. So, these are the four basic operation performed on the queue: insert at the front, which helps to insert element from the front side; insert at the last, which helps to insert element from the rear side. Similarly, delete front, which helps to delete element from the front side; delete last, which helps to delete element from the rear side. Also, we can write an algorithm uh, in which we can have these four functions: insert at the rear, insert at the front, delete at the rear, delete at the front. Out of them, we have perform insert at the rear, we have perform delete at the front. Similarly, we can write functions, we can write algorithms to insert element at front as well as to delete element from rear. Just we have to manage the values of front and rear. Next type of the queue is priority queue. uh, Basically, in computer science, a priority queue is an ADT, which is exactly like a regular queue or stack data structure, but additionally, it is having one more element which is known as priority, and element which is get inserted and deleted by using priority. That is, when we have priority queue, along with each element there is a priority. Therefore, an element which is having the highest priority is served first into the queue, then element which is having lower priority is get served. That is, in case the concept of the priority queue is, with each element we have priority. Element which is having highest priority is get served first. Similarly, as we have implemented linear queue, we have implemented circular queue. Similarly, we can implement priority queue. While adding and deleting element, we have to consider priority value. If the priority value is the highest, then only we can insert an element into the queue. Then what are the applications of queue? There are, in real life there are so many situations when we make use of uh, such a queue. These are few listed application. Queue is useful in CPU scheduling. Queue is useful in disk scheduling, as we are having multiple scheduling algorithm like FCFS, round robin. There are still more scheduling algorithms, and all those algorithms make use of queue. That is, we can say queue is helpful in CPU scheduling as well as in disk scheduling. Also, when multiple processes require CPU at the same time, at that time various CPU scheduling algorithms are used, which are implementing which are implemented by using only queue as a data structure. Also, queue we can use for various synchronization purposes. For example, IO buffer, pipes, files, IO, etc. In this way, there are so many applications of queue. Uh, in this way, in this lecture, what we have seen, what do you mean by queue? Queue is a data structure in which an element which is inserted first, it's come out first. It is also known as FIFO kind of data structure. We have seen queue as an ADT, that is abstract data type, where we have following operation: it's full, it's empty, NQ, DQ. Also, we have gone through the types of linear queue. Sorry, also we have gone through types of queue, that is linear queue, circular queue, double-ended queue, priority queue. In linear queue, we have seen element get inserted linearly sequentially by using by incrementing front and rear values linearly, as front equal to front plus 1, rear equal to rear plus 1. But this linear queue is having several drawbacks. The drawback is we cannot insert an element at previous location because it is linear queue. Front and rear values are moving linearly. Here we do not have any chance to back rear values, so this drawback is get overcome by circular queue. In circular queue, we update formula for front and rear as front equal to front plus 1 mod size, rear equal to rear plus 1 mod size. And by using this formula, we can we can insert an element at previous location. Then we have seen the concept of double-ended queue. In double-ended queue, insertion and deletion, it's possible from both end. That is, double-ended queue has two types: input restricted queue, output restricted queue, where we can perform insertion from rear as well as we can perform insertion from front. In double-ended queue, it is possible to delete an element from the front. Also, it is possible to delete an element from the rear. We have also seen the concept of priority queue. In priority queue, with each element we have priority associated with it, and element which is having the highest priority is get served first. Also, we have seen applications of queue, as queue is used in various scheduling algorithms like FCFS, round robin. Queue is used in various disk scheduling algorithms. Also, queue is used in various synchronization concept like pipes, IO buffer, etc. There are still so many applications of queue. Thank you.